faster than the fabric of space-time can keep up with it. And it'll just rip. And I'm terrified by this.
The James Webb Space Telescope, JWST, one of the most advanced pieces of astronomical technology humanity has ever created, has taken a pivotal step in expanding our understanding of the universe. In a recent revelation, renowned astrophysicist Neil DeGrasse Tyson discussed how the telescope might have captured evidence pointing to the existence of another universe. This groundbreaking discovery challenges not only our perception of the cosmos, but also the fundamental principles of physics, potentially rewriting the very laws that govern reality as we know it. Before we start, please don't forget to like and subscribe to our channel for more updates. Tyson, known for his ability to translate complex scientific phenomena into digestible and fascinating narratives, delved into what this potential evidence could mean for humanity. For decades, scientists have speculated about the concept of a multiverse, the idea that our universe is just one of many, coexisting in a vast and complex system of realities. These parallel universes, while theoretically possible, have long been considered unobservable, existing beyond the reach of our instruments and technologies. However, the JWST has now provided a glimmer of hope, a sign that these hidden realms might not be as inaccessible as once thought. The James Webb Space Telescope, launched in 2021, has far exceeded expectations in its ability to peer into the deepest corners of space. Equipped with an array of highly sensitive instruments, including infrared detectors, the JWST is capable of capturing light from the earliest moments after the Big Bang. Its unprecedented clarity and resolution allow scientists to observe celestial phenomena that have remained hidden from view. Now it seems that these capabilities may have unveiled something far more significant than just distant galaxies. It might have detected the influence of another universe. Tyson explained that the evidence the JWST captured could be in the form of strange anomalies in the cosmic microwave background, CMB, the faint afterglow left over from the Big Bang. These anomalies, while subtle, appear to suggest that some form of external force is acting upon our universe. The CMB has long been a cornerstone of cosmological research, providing scientists with crucial insights into the early stages of our universe's development. However, the patterns identified in recent JWST observations differ from anything previously seen. What makes these observations even more tantalizing is the possibility that they could represent a cosmic bruise, a phenomenon predicted by certain multiverse theories. According to these models, different universes might occasionally collide or brush against each other, leaving detectable marks in the fabric of space-time. If the JWST has indeed captured evidence of such an event, it would not only confirm the existence of other universes, but also provide direct proof of interactions between them. The implications of this discovery are profound. If there are indeed other universes beyond our own, each could operate under a completely different set of physical laws. Some might resemble our universe closely, while others could be utterly alien, with fundamental forces like gravity, electromagnetism, and even time behaving in ways we cannot imagine. This raises questions about the nature of reality itself. What if our universe is just one small piece of a much larger, infinitely complex system? The possibility of other universes also has significant implications for our understanding of life. One of the most enduring questions in science is whether life exists elsewhere in the cosmos. While the discovery of extraterrestrial life within our own universe would be groundbreaking, the existence of other universes opens up entirely new possibilities. There could be countless realities, each with its own unique conditions for life to evolve. Some universes might be teeming with life forms vastly different from anything we could conceive, while others might be devoid of life entirely. Furthermore, this discovery challenges the anthropic principle, the idea that the universe appears fine-tuned for life because we are here to observe it. If there are an infinite number of universes, it would make sense that at least one would have the right conditions for life as we know it. This shifts the conversation from "why is our universe special?" to "how many other universes exist that might be just as special?" The realization that our universe may not be unique diminishes the notion of a singularly designed cosmos and opens the door to a broader understanding of existence. Tyson also touched on the philosophical implications of this discovery. The existence of other universes forces us to confront questions about the nature of existence itself. If multiple realities exist, each with its own version of physics, time, and space, what does that say about the concept of truth? Is there an objective reality, or is reality simply a construct that varies from universe to universe? These are questions that have traditionally been the domain of philosophy. But now, with the potential evidence from the JWST, they are becoming questions that science must grapple with. One of the most exciting aspects of this discovery is that it could represent the first step toward a new era of exploration. Just as the development of telescopes in the 17th century revolutionized our understanding of the solar system, the capabilities of the JWST might be the key to unlocking the mysteries of the multiverse. If scientists can confirm the existence of other universes and develop methods for studying them, it could lead to a new frontier of research, one that transcends the boundaries of our own reality. However, there are still many unanswered questions. While the data captured by the JWST is compelling, it is far from conclusive. Tyson emphasized the need for further investigation and analysis to determine whether the anomalies observed in the CMB are truly the result of interactions with another universe or simply an unexplained quirk of our own universe. This will require years of additional observations, simulations, and theoretical work. The potential discovery of another universe also raises significant challenges for current scientific theories, particularly in the field of physics. The standard model of particle physics, which has been remarkably successful in explaining the behavior of subatomic particles, is based on the assumption that our universe operates under a specific set of physical laws. If other universes exist with entirely different laws, it could require a complete overhaul of this model. Similarly, Einstein's theory of general relativity, which describes the nature of gravity and spacetime, might need to be modified or expanded to account for the existence of multiple realities. Despite these challenges, the scientific community is buzzing with excitement over the possibilities that the JWST's observations have opened up. This discovery could be the first step toward answering some of the most profound questions about the nature of the universe. Are we alone in our reality, or are there countless other universes waiting to be discovered? What lies beyond the observable cosmos? These are questions that have fascinated humanity for millennia, and for the first time, we might be on the verge of finding answers. Tyson's revelation about the JWST's potential discovery also highlights the importance of continued investment in space exploration and scientific research. The telescope's ability to capture such detailed and unexpected data demonstrates the value of pushing the boundaries of technology and human knowledge. As we continue to develop more advanced instruments and techniques, our capacity to explore the universe, and perhaps even other universes, will only grow. The idea that our universe is not the only one is no longer just a speculative concept relegated to the realm of science fiction. With the potential evidence gathered by the JWST, the multiverse is now a topic of serious scientific inquiry. This shift in thinking marks a profound moment in the history of science, one that could lead to a fundamental transformation in our understanding of reality. The discovery of another universe would also have a significant impact on our cultural and societal perspectives. Throughout history, humans have constantly redefined their place in the cosmos. From the geocentric model of the universe to the heliocentric model, from the belief in a flat Earth to the understanding of a vast expanding universe, our view of the cosmos has continually evolved. The realization that our universe is just one of many would be another monumental shift, forcing us to rethink our place in the grand scheme of existence. This potential discovery also brings into focus the limitations of human perception. For centuries, we have relied on our senses and technological extensions of those senses, like telescopes and satellites, to understand the universe. But if there are other universes with different physical laws, it is possible that our instruments are ill-equipped to detect them fully. This raises the intriguing possibility that there could be aspects of reality that we are fundamentally incapable of perceiving, no matter how advanced our technology becomes. The potential discovery of another universe by the James Webb Space Telescope, JWST, is a revelation that could have reverberations across every facet of human knowledge. It transcends the boundaries of physics, astronomy, and cosmology, forcing us to rethink our understanding of existence itself. While the evidence is still being analyzed, the implications of this finding go far beyond scientific circles and challenge long-held notions about reality, consciousness, and the very fabric of space and time. To fully grasp the significance of this potential discovery, it's important to understand the context in which it occurred. The JWST, designed to observe the earliest galaxies formed after the Big Bang, is equipped with technology capable of capturing light that has traveled for billions of years. This gives scientists the ability to look back in time, studying the universe in its infancy. However, in doing so, the telescope has encountered phenomena that do not conform to our current understanding of the cosmos. The most compelling of these anomalies are in the form of irregularities in the cosmic microwave background, CMB, which has led scientists to speculate that they may be the result of interactions with another universe. The multiverse theory, which proposes the existence of multiple, possibly infinite universes, has been a topic of serious scientific discussion for decades. It is not a single theory, but rather a collection of models that suggest our universe is part of a much larger and more complex system. The multiverse could be infinite in scope, with each universe having its own set of physical laws, constants, and particles. Some of these universes could be nearly identical to ours, while others might be radically different. These different realities may coexist with ours, but they have remained undetectable until now. What makes the JWST's findings so exciting is that they offer a potential observational basis for this theory. While previous discussions of the multiverse have been largely theoretical, the possibility that we are now seeing direct evidence of another universe pushes this concept into the realm of empirical science. This shift from theory to observation represents a monumental leap in our understanding of the cosmos, with consequences that ripple through numerous disciplines. One area where this discovery could have a profound impact is in the field of theoretical physics. For decades, physicists have sought a theory of everything, a single framework that can explain all the fundamental forces of nature. Currently, the Standard Model of particle physics and Einstein's general theory of relativity are the two pillars of our understanding of the universe. However, these theories are not fully compatible, particularly when it comes to explaining gravity at the quantum level. The discovery of other universes could provide the missing pieces needed to reconcile these two frameworks. One possibility is that these universes are manifestations of string theory, a theoretical framework that suggests all particles are composed of tiny, vibrating strings. String theory predicts the existence of multiple dimensions beyond the three spatial dimensions we experience. Some versions of the theory suggest that our universe is just one of many brains, three-dimensional slices of a higher dimensional space, floating in a higher dimensional space known as the bulk. These brains could occasionally collide, creating the observable effects we interpret as a Big Bang or leaving traces in the form of cosmic bruises. If the JWST has indeed captured evidence of another universe, it could provide much-needed support for string theory, offering an explanation for how these universes interact and influence one another. Beyond the purely scientific implications, the idea that our universe is just one of many carries profound philosophical consequences. Since the dawn of human consciousness, we have struggled to understand our place in the cosmos. For centuries, Earth was considered the center of the universe, with the heavens revolving around us. The Copernican revolution shattered this belief, showing that our planet is just one small piece of a much larger solar system. Over time, our understanding of the universe expanded even further, revealing that our solar system is just one of billions in a galaxy, and our galaxy is just one of billions in the observable universe. The potential discovery of another universe takes this process of decentering humanity one step further. If there are indeed multiple universes, then our universe is not even unique. We are not living in the one and only cosmos, but in one of potentially infinite realities. This realization forces us to confront the possibility that our existence, far from being central or special, is just one of countless permutations of reality. While this idea may seem humbling or even unsettling, it also offers a new perspective on the nature of existence. If the multiverse is real, it means that every possible version of reality might exist somewhere. Every choice we make, every event that occurs, could lead to a different universe in which a different outcome occurs. In one universe, you might have chosen a different career path or moved to a different city. In another, entirely different physical laws might exist, leading to a universe where gravity operates in reverse or time flows backward. The implications of this are mind-boggling and challenge our understanding of free will, determinism, and the nature of causality. Moreover, the multiverse theory raises intriguing questions about consciousness. If there are infinite versions of reality, does that mean there are infinite versions of ourselves, each experiencing a different life? Are these different versions of us truly separate? Or are they somehow connected at a deeper, fundamental level? Some interpretations of quantum mechanics suggest that consciousness plays a role in the collapse of the wave function, the process by which a quantum system transitions from a superposition of states to a single observable state. In a multiverse scenario, each time a quantum event occurs, the universe could split, with each possible outcome occurring in a different reality. If this is true, it suggests that consciousness is not just a passive observer of reality, but an active participant in shaping it. The discovery of another universe would also have significant implications for religion and spirituality. Throughout history, many religious traditions have taught that the universe is the creation of a divine being, designed with a specific purpose in mind. The existence of a multiverse complicates this idea, as it suggests that our universe is not the product of a singular act of creation, but one of many possible realities. This raises questions about the role of a creator in the multiverse. If there are infinite universes, does each one have its own creator? Or is there a single creator overseeing the entire multiverse? Alternatively, is the multiverse itself a self-sustaining system, operating according to its own inherent laws without the need for a creator? These questions challenge traditional religious beliefs, but also offer new opportunities for spiritual exploration. Some theologians might argue that the existence of a multiverse expands the scope of divine creation, demonstrating the infinite creativity and power of a higher being. Others might see the multiverse as evidence that the universe is a more complex and mysterious place than we can comprehend, inviting us to embrace the unknown and seek deeper understanding. In addition to its philosophical and spiritual implications, the discovery of another universe could revolutionize our approach to science and technology. If other universes exist with different physical laws, they might offer new insights into how our own universe works. For example, scientists could study the properties of these other universes to learn more about the fundamental forces that govern our reality. This could lead to breakthroughs in fields like quantum mechanics, particle physics, and cosmology, as we gain a deeper understanding of the underlying principles that shape the cosmos. Furthermore, if we can develop the technology to detect and study these other universes, it could open up entirely new avenues of exploration. Just as the JWST allows us to observe distant galaxies and peer back in time, future telescopes or instruments might be able to detect the presence of other universes, or even allow us to interact with them. This could lead to the development of technologies that seem like science fiction today, from interdimensional travel to communication with parallel realities. The potential applications of such technology are vast. Imagine a future where we can travel between universes, exploring different versions of reality, and learning from the civilizations that inhabit them. This would be the ultimate frontier of exploration, far surpassing the boundaries of our current understanding of space travel. It could also offer solutions to some of the most pressing problems facing humanity, from finding new resources to combating climate change. If other universes exist with different physical conditions, they might offer new sources of energy or environments where life can thrive. The possibilities are endless. However, the discovery of another universe also raises ethical and practical questions. If we are able to interact with other universes, how should we approach these new realities? Should we treat them as resources to be exploited, or should we approach them with caution and respect, recognizing that they may contain life forms and civilizations that are vastly different from our own? These questions will require careful consideration as we move forward in our exploration of the multiverse. Another area where the discovery of a multiverse could have a profound impact is in the study of dark matter and dark energy. These mysterious substances make up the vast majority of the universe's mass and energy, yet we know very little about them. Dark matter is thought to be responsible for the gravitational effects that hold galaxies together, while dark energy is believed to be driving the accelerated expansion of the universe. However, despite decades of research, scientists have been unable to directly detect either dark matter or dark energy. The existence of other universes could provide new insights into these enigmatic phenomena. Some theories suggest that dark matter and dark energy could be manifestations of other universes interacting with our own. For example, the gravitational effects attributed to dark matter might be caused by the influence of matter in a parallel universe, while dark energy could be the result of forces acting across different realities. If the JWST has detected evidence of another universe, it could help scientists develop new models for understanding dark matter and dark energy, potentially leading to breakthroughs in our understanding of the universe's structure and evolution. The discovery of another universe by the James Webb Space Telescope, JWST, if confirmed, will not only redefine our understanding of the cosmos, but could also fundamentally alter the trajectory of human thought, technology, and culture. The notion that our universe might be just one in an infinite series of universes introduces a new and unprecedented paradigm in cosmology. Beyond the scientific, philosophical, and existential implications, the potential discovery of another universe opens up new realms of possibilities in areas like cosmological theory, human exploration, artificial intelligence, and even the arts. The idea of a multiverse had long been the domain of theoretical physicists, mathematicians, and science fiction authors. But now, with the JWST's data providing what might be the first empirical evidence of another universe, it feels as though humanity is on the cusp of breaking into a new intellectual and technological frontier. These new universes could operate under physical laws that differ drastically from our own, introducing forces, particles, and phenomena never before imagined. They could help solve existing conundrums in our current theories, or provide an entirely new framework for understanding reality. One of the most fascinating potential impacts of this discovery is how it might influence our understanding of time. In our universe, time is generally understood as linear and unidirectional. It flows forward from the past, through the present, and into the future. But other universes might not follow the same temporal laws. Some theoretical models suggest the existence of universes where time moves backward or flows in multiple directions. Others propose the existence of cyclical universes where time resets itself periodically. This could mean that in some universes the arrow of time may not exist at all, and past, present, and future could be interchangeable or indistinguishable. If we are able to confirm the existence of such universes, it would profoundly impact our understanding of causality and the nature of events. The implications for physics would be enormous, potentially requiring the rewriting of large sections of relativity and quantum mechanics, particularly in the way they describe space-time. It could also influence how we think about the origin and fate of our own universe. If time operates differently in other universes, could it be possible to transfer information or energy across different timelines? Could certain anomalies in our own universe, such as inexplicable gravitational waves or dark energy fluctuations, be evidence of temporal interactions with another universe? Another groundbreaking implication would be how the discovery of other universes could revolutionize human space exploration. At the moment, humanity's vision for space exploration is confined to our own solar system and galaxy. But if other universes exist and if they can somehow be accessed, this opens up entirely new realms for exploration. In the far future, humanity might develop the technology to travel between universes, discovering realms where different physical constants apply. Some universes might have stronger or weaker gravitational fields, which could allow for the development of new forms of energy and space travel. Imagine a future where advanced spacecraft could move between universes, using inter-universal travel not only to explore but to gather resources, solve technological challenges, or even provide new habitats for humanity. While this is speculative for now, the discovery of other universes will likely push engineers and scientists to begin thinking about the practical implications. How might energy fields, propulsion systems, or materials differ in a universe where physics follows different rules? Could we harness those differences to overcome the barriers to space exploration in our universe? One potential way of exploiting these differences lies in energy generation. If other universes have different laws of thermodynamics or sources of energy, it might be possible to access forms of energy that are simply not feasible in our own universe. These might include exotic particles, gravitational phenomena, or electromagnetic fields that operate on a scale far beyond anything we can currently imagine. The possibility of tapping into multiversal energy sources could end humanity's reliance on finite resources, such as fossil fuels or even nuclear energy. It could allow the development of clean, unlimited energy derived from entirely new principles of physics. The multiverse could also change how we think about life and biology. For centuries, humanity has wondered whether life exists elsewhere in the universe. The discovery of other universes could vastly expand the potential habitats for life, with each universe providing its own unique environments, chemistry, and ecosystems. Some universes might have conditions similar to Earth, while others could be so alien that life as we know it could not exist. In those cases, entirely new types of life forms, perhaps based on silicon, plasma, or other exotic elements, might exist, thriving in environments that would be inhospitable to human beings. This raises profound questions about evolution, adaptation, and the nature of life itself. How might life evolve in a universe where gravity is weaker, or where light behaves differently? Would intelligence and consciousness emerge in the same way, or would entirely new forms of sentience develop? The discovery of other universes could spark a renaissance in biology and astrobiology, prompting scientists to rethink the very definitions of life and intelligence. Additionally, this discovery could redefine our search for extraterrestrial intelligence, SETI. Currently, efforts to find intelligent life are focused on our universe, using radio waves and other signals to search for civilizations in distant galaxies. But if there are other universes, particularly those in close proximity to ours, it might be possible to develop new methods for inter-universal communication. The possibility that intelligent life might exist in another universe opens up new questions about how to detect and communicate with such beings. Would they experience time in the same way? Would they understand our methods of communication? And what would they make of a civilization from another universe attempting to make contact? The multiverse concept also challenges the very notion of uniqueness in cosmology. Currently, our universe is understood as the product of a singular event, the Big Bang, which created all matter, energy, and the laws of physics. But if other universes exist, it challenges the notion that the Big Bang was a singular, all-encompassing event. It may have been just one of many cosmic creation events, each producing its own universe with its own unique characteristics. This realization could reshape the way cosmologists study the origin of the universe, prompting new theories about how universes form and what triggers their creation. One theory that has gained traction in recent years is the idea that our universe exists in a multiverse where new universes are constantly being created. These new universes could emerge from quantum fluctuations, black hole singularities, or other cosmic phenomena, creating a never-ending cycle of universe creation. This model, sometimes referred to as the eternal inflation theory, suggests that the Big Bang was just one in a series of similar events, each giving rise to a new universe. The discovery of another universe by the JWST could lend support to this theory, providing observational evidence for the idea of a constantly expanding multiverse. In addition to the implications for physics, biology, and cosmology, the discovery of another universe could have profound effects on the humanities, particularly in the realms of philosophy, art, and literature. For centuries, philosophers have debated the nature of reality, consciousness, and existence. The multiverse theory, if confirmed, would introduce new dimensions to these age-old debates, forcing thinkers to grapple with questions of identity, free will, and the nature of truth. If there are multiple universes, each with its own version of reality, what does that say about the concept of objective truth? Is truth universal, or does it vary from universe to universe? These philosophical questions could inspire new schools of thought, much like the philosophical revolutions of the past, such as the Enlightenment or the birth of existentialism. Philosophers might explore the ethical implications of interacting with other universes, considering questions such as whether we have a moral responsibility to protect or preserve other universes, or whether it would be ethical to exploit their resources. They might also grapple with questions of identity, asking whether individuals in our universe have counterparts in other universes, and if so, what that means for our understanding of the self. Artists and writers, too, will likely be inspired by the discovery of other universes. The concept of the multiverse has already been a rich source of inspiration for science fiction authors, filmmakers, and visual artists, and the confirmation of its existence would only fuel further creativity. Artists might explore the visual possibilities of other universes, imagining how different physical laws could shape the appearance of landscapes, objects, and beings. Writers might delve into the psychological and existential implications of the multiverse, crafting stories about characters who discover their counterparts in other universes or who travel between realities. The arts could also provide a way for people to process the emotional and existential impact of this discovery. For many, the realization that our universe is not unique might be difficult to comprehend, challenging long-held beliefs about the nature of reality and humanity's place in the cosmos. Through painting, sculpture, music, and literature, artists can help society come to terms with these ideas, offering new ways of understanding and interpreting the multiverse. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what do you think this discovery could mean for our understanding of space? We want to hear from you. Thank you for watching and see you next time.